we can extract two information from the dipole moments. One is the percentage of the ionic character of the bonds can be calculated, can be determined, and second, it can tells you about the geometry of the molecule. So for example, over here we have some molecules, and from their dipole moments we can determine the geometry of the molecule. Like in case of carbon dioxide, okay, to this carbon central atom we have just two bonded atoms. So to minimize the electron repulsion, these are at a maximum distance apart, making a linear geometry by 180-degree angle. Same is the case in beryllium dichloride with a net dipole moment equal to 0, and these two molecules are considered to be a nonpolar in nature. In case of the AB3 type molecule with no lone pair, like aluminum trichloride, aluminum trihydride, and boron trifluoride, in all these cases, although the bond moments, they are polar in nature, but all the three molecules are considered to be a non-polar, because of the net dipole moment is equal to 0. And these molecules, to minimize that electron repulsion, they are at a maximum distance apart, and the geometry of this molecule is trigonal, and each with a 120-degree angle. In case of AB4 molecules, like in case of methane, we have all the four surrounding atoms are bonded in nature. In case of ammonia, we have three bonded pairs and one lone pair. In water, we have two bonded and two lone pairs we have. In case of tetrahedral, although guys, it seems to you, okay, like these three bonds are very close to one another and this one is a very far, but no, in three dimension all the four are equally spaced from one another, and they cancel the two opposite which are equal in magnitude and opposite direction, they cancel the effect of each other, making the net dipole moment equal to 0. And this methane molecule, although it is having a little electronegativity different between a carbon hydrogen, but this molecule as a whole is non-polar in nature. In case of ammonia, if we make a resultant vector of these three bond pairs between nitrogen hydrogen, that will be pointing somehow downward, whereas the dipole moment for this lone pair, that will act in a in an upward direction, so that may be not equal in magnitude to the downward one, and that cannot cancel the effect of each other, and the net dipole moment in case of ammonia, that is equal to 1.47 dpi. In case of water molecules, if we look, okay, we have two bond pairs and two lone pairs, so if we make a resultant vector of these two bond pairs, so that will definitely act in a downward direction, and the lone pairs will act in a upward direction. So again, these two above and below dipole moments, for the bond pairs and for the lone pairs, they may not be equal in magnitude, but they are in opposite direction. So as a result, for the water, the net dipole moment, we do have some value, and that is equal to 1.84 dpi. In case of this another molecule, you can see, okay, the chlorine, the two chlorine, they are attached to opposite sides, they are at transposition, cancelling the effect of each other because they are equal in magnitude and opposite in direction. And same is the case for these two hydrogen, they are having same magnitude, and they are opposite in direction, so the net dipole moment for this molecule, that is equal to 0. In case of this molecule, you can see, okay, we have the chlorine attached to one side, it's a cis type, it is a cis type, and you can see in both the molecules we have a doubly bonded carbon atom. So in this case, if we make a resultant vector for these carbon and chlorine, that will act in an upward direction, but if we draw a dipole moment for carbon hydrogen, that will act in a downward direction. So maybe these two vector, they may not be equal in magnitude, but they are in opposite direction. Therefore this for this molecule, for this cis isomer, the net dipole will not be equal to 0, and as a result this molecule will be a polar in nature. This is a trans isomer, and this is a cis isomer, and this is the trans isomer. Okay, the first point was to calculate the percentage